All right, I'm going to do a video on fractions in case you're interested, but you're supposed to be getting a calculator and getting comfortable trying to use that calculator. But I thought I'd just go through some of the things you need to do with fractions sometimes. So like a lot of times we're needing to simplify fractions. Like the last step of just about any fraction problem will involve trying to simplify it. So if you had a problem like 12 over 18, you would look to see what's common. And if you could determine the biggest thing common to both, you would divide the top and the bottom by that number, and you'd wind up with your final answer. Now, sometimes I'm looking at something, and for instance, 15 divided by 75, I can see the 5 at the end. That's something that tells me 5 would go into that. And when I divide 15 by 5, I get 3. When I divide 75 by 5, I get, what do I get? I get 15, okay? And then when I look at that, that's not completely simplified. I can tell that 3 would have gone into both the top and the bottom. And so if I did that, I'd wind up with 1/5. Okay, my pen is I dropped it, and so it winds up not connecting good in spots, but I think you'll be okay. You'll be able to follow me. Right? And then if you're trying to convert between mixed numbers and improper fractions, right, here's what you do there. If you're starting with a mixed number and you want it to be an improper fraction, it's like this, you would read it as 3 and 1/4. That's like 3 whole and 1/4 of something else. And so the idea there is you would take the 3 times the 4 parts, okay, plus the 1, and put all of that over the 4. So it's 3, you multiply those two, and then add this guy, okay? So 3 times 4 plus 1, that would be 12 plus 1. So that's going to be 13 over 4. Okay. Now the other way, we utilize division. We know that that means division. So we're going to find out how many fifths there are in 42. So we're going to do that by taking 5 and dividing it into 42. Okay. And if we do, that goes in there 8 whole times. And that would be 40. And we have a remainder of 2. And so 42 fifths is the same as 8 wholes with 2 fifths left over. So we have 8 wholes and then 2 fifths. Okay? So that would be your final answer. And again, all of this can be done using the fraction keys on a calculator. So part of your job is to get the calculator you're planning to use and then use your fraction keys to work through that. All right, so let's see. If we're trying to add and subtract fractions, that's the one that requires the common denominator. So let me make a little note there. You need common denominators. And with multiplying fractions, you don't need common denominators. That's the mistake people make, is they mix up these two denominators. Okay, so if you're trying to do something like 3/4 plus 1/2, you would look at the 4, look at the 2, and you would think about what would be a good thing to use for the denominator there. Okay. And I think a good thing to use would just be 4. So 3/4 would be good to go. And then with the 1/2, I would have to multiply. Let me see if I can find the tools here. I'm not sure this is actually taping. Okay, let me get my red. I would multiply here by 2. And then on top by 2, and I would then rewrite 1/2 as 2/4, and so 3/4 plus 2/4 would be 5/4, most of the time you're going to want to leave your answer as a fraction in simplest form. I want to change this problem a little bit, just so it's not exactly the same type as before. So let's suppose on this one that, let me just fix it right here. Let me go in. I should have fixed something that had a different thing happen. Let's suppose that's 12 down there. Okay. All right, so if I'm trying to do 5/8 minus 1/12, on this one, see how on the one above 4 was good enough as the common denominator? 2 would go into it. But here I would have to look at those two numbers and find a common denominator. So one way to do it is to take the 12 and think, does 8 go into 12? But it doesn't. Then go to the next multiple of 12, which is 24, and then think, does 8 go into 24? And it does. In other words, if we looked at the list of multiples, 24 would be in both of them. Okay. So here's what we're going to do. We're going to rewrite the first fraction so it has that denominator. And we're going to rewrite the second fraction so it has that denominator. Okay. All right, so what we need to do is to turn 8 into 24, we'd have to multiply by 3. And if we do that on the bottom, we have to do that on the top. So 5/8 becomes 15/24. Okay. Now with 1/12, I would have to multiply by 2 on the top and bottom and get 2/24. Right, and then I was subtracting, so I'm bringing that back in. But now I have the like fraction, same type thing. 15/24, take away 2/24, I would have 13/24 left. Okay, and that would be your final answer because 13/24 can't be broken down anymore. All right, if I'm multiplying fractions, what I do there, don't try to get common denominators, just multiply straight across. So this would be 3/8, and then you would look to see if it could be simplified, but it can't, so that's your final answer. Right? And then on this one way to do it is to just multiply straight across. I'd get 80. Down on the bottom, I'd have 15 times 12. So what is that? 120, 180. Okay. And then I could divide. I know I could divide by 10. That would knock off the 0. That would get me to 8/18. Then I'm thinking I can divide by 2 for sure. That would get me 4/9. And then I'm thinking there's nothing else I can do. Okay, now had I looked harder initially, I could have maybe seen that 20 would go on into the top and the bottom. But normally I just, whatever I notice, I go ahead and divide out. All right, now if this makes sense, this is a really good way to handle it, especially later in Math 100 when you do this with variables in it. You also can do this if this makes sense. Because multiplication is just multiplying straight across, you can look for common factors on the top and bottom. In other words, you can simplify before you multiply. So I noticed that, for instance, I could divide here by 4, and there'd be 2 left, divide here by 4, and there'd be 3 left. Okay, then I noticed I could divide here by 2, and I'd have a 5. I could divide here by, I shouldn't have divided by 2. Let me divide by 5. Divide by 5, and there'd be a 2. Divide by 5 down there, and there'd be a 3. And then there's nothing else common on the top and bottom to cancel out. So there's a 2 times 2 or 4 on top and a 3 times 3 or 9 on the bottom. That's the other way to do it, where you go ahead and cancel out any common factors on the top and bottom before you multiply. Otherwise, you go ahead and multiply and then just work on getting simplified at the end. All right, now with dividing fractions, you just need to keep, change, flip. So you're going to keep the 3/8, change to multiplication, and take the reciprocal of 1/2. That would give you 2 or 2/1. Then you're back to multiplying, and if you liked that idea of canceling out, see multiplying, you just multiply straight across, And there's a 2 on top, and 2 goes into 8 4 times. So our final answer would be 3 times 1, or 3 over 4. Okay, 3/4. Now, if you didn't do that, you could have said 3 times 2 is 6, over 8 times 1 is 8, and then simplified to 3/4. Okay. All right, so let's do the same thing here. We got to keep, we got to change, and then we're going to flip. Okay. And then actually there's not going to be anything that you can cancel out because nothing can be canceled out from the top and bottom. So if we multiply straight across, we'd get 36 on top and 125 on the bottom. And that's as good as that one gets. All right, now with mixed numbers, I'm just doing a couple examples. I'm doing an adding and a dividing on this. See, I put them both together. The thing I recommend you do with mixed numbers is either just use your fraction keys. Okay, so if you're going to use your fraction keys, you can type in the mixed number. You can do 1, hit the ABC button, do 3, hit the ABC button, and then 8s. You can type them in just like that. If you don't use your calculator, you're doing it by hand, I recommend you just convert each of these to improper fractions. So that's 1 times 8 plus 3. So multiply these guys and then add that one. 2 times 2 plus the 1. Okay, so you would wind up with 8 plus 3 is 11 eighths. Okay, and then here 4, 5 halves. So you're trying to add 11 eighths plus 5 halves. Okay, 11 eighths plus 5 halves. All right, now at that point you're adding, so you would have to get common denominators. So that's where you should think about what you have to multiply by. So I'd have to multiply the denominator by 4 and the numerator by 4 to get a common denominator of 8 going on. Let me go back to the red. So this is 11 eighths plus 20 eighths. And now that I have eighths, I can do 11 plus 20. That's 31 eighths. Okay. All right, and then here we have division. So what I would recommend is that you convert it to a improper fraction. So you're going to multiply and then add. 2 times 4 is 8 plus 3 is 11 fourths. 3 times 3 is 9 plus 1 is 10 thirds. Remember how you just do that, multiplying, and then you add that 1. Okay. All right, and then in between, we still have division. I haven't done any flipping or anything. Now I'm going to keep it, change it, flip it. Okay. Then I'm going to look for something common on the top and bottom, or I'm going to go ahead and just multiply straight across and then do that after I get to here. But nothing goes into both 33 and 40. So that should be my final answer. Okay. So I just wanted to do a little video on fraction operations because I think some of you are interested, but you can do these just using the fraction keys on your calculator.